This section deals with solving equations. So, first, we want to talk about what an equation is. An equation is a mathematical sentence stating that two expressions are equal. So, if you do not have an equal sign, then you do not have an equation. And so, you first want to make sure that you know what you're doing. If it's just simplifying, there is no equation, there is no inequality, then you're just combining like terms, like we've done. But if there's an equation, that means you're likely going to solve for something. And so that's what you're going to look for in this particular. Then we want to talk about the truth. So you would have talked about truth value in the prior classes. And so the truth of a conditional equation depends on that value of the variable. So the value of the variable that makes the equation true is called the solution. And so if it makes the statement true, it is a solution. And that is all conditional on what you plug in for that variable. Let's review some of the properties of equality. So the reflexive property, I like to think of it as a reflection. It just means that one thing equals itself. It seems like you don't need to say that, but that helps us when we're moving things across that equal sign. The symmetric property tells us that we can flip whatever's on each side of an equation. So if you have something like this, -3y equals 6, you can also say that 6 equals -3y. Some people like to have all their variables on one side, and it really doesn't matter as long as you keep everything the way it is and flip the entire equation across. The transitive property says that if A equals B and B equals C, then A equals C. This is going to help us when we start setting things equal to each other. So if we have something equal to this variable and then this variable equal to another expression, those two are equal to each other. The addition property of equality says that whatever we add to one side, we add to the other to keep it equal. And then the multiplication property tells us the same thing, but with multiplication. If we have an equation, whatever we multiply to one side, we need to multiply to the other. Think of it as a scale or a balance. We need to keep it balanced. And so if you add weight to one scale, you have to add weight to the other side. If you multiply it by a factor, you need to multiply the other side by a factor. Two equations then are considered equivalent if they have the same solution. And so the addition and multiplication properties, if they are applied correctly, produce equivalent equations. We actually haven't changed the fact that they're equal as long as we do the same thing to both sides. So let's look at how this is practiced. The first thing we're going to want to do is get rid of those parentheses. And remember, we're going to do that with distribution. So we're going to take this -3 and we are going to distribute it through to the entire parentheses. So we're going to say -3 times x, -3x, -3 times +2. Remember, negative times a positive is a -6 here. Then on the other side, we are going to distribute that 4 times x is 4x. 4 times 18 is going to give us 72. And don't forget you have a -1 on the end there. The next thing that we're going to do, so after we distribute to get rid of any of our parentheses, we want to combine like terms. Now remember, if it is on the same side of the equation, we are not moving it across, we are simply combining. So we're going to look for simplifying each side individually. This is a -3x, this is a -6. Those are not alike, so we are going to leave those alone. This -4x, this +4x does not have a like term, but these are like terms, so we're going to go ahead and do those. 72 minus 1 is 71. Now we're going to look at moving things across that equal sign. So once we have simplified both sides, then we are going to start moving things across the equal sign, meaning we want variables on one side, numbers on the other. And so if you always like your variables on the left, then we're going to move this 4x over. Remember, when it moves across that equal sign, we need to change the sign. So this is a +4x here. We want it to be a -4x, so it will zero out. And remember, if we have a -4x on one side, we need a -4x on the other. And so we are going to zero that one out. We're going to use our addition here. -3 plus -4 is -7x. And so we have successfully moved the variable to that side. Now we want to move the numbers then to the other side. So we're going to take that 6 and we're going to move it to the other side. It is a -6 here because we're moving across the equal sign. We want to make that a +6. And once again, we have successfully zeroed that out. So we are able to cancel it on that left side here. And we have 77 on the other. One thing I do want to point out is don't lose that equal sign. That equal sign is still there. And so we want to make sure we bring that down. So what we're doing on this third step is we are moving our variables to one side and our numbers to the other. And we're at our final step, which is to divide our coefficient across. So we want the x to be completely by itself. It has a -7 in front of it, so we are going to divide both sides by that -7. On this, we have successfully canceled out our coefficient. We have just x. Don't forget, you do have an equal sign. And then we're just doing division here. 77 divided by -7. Remember, positive divided by a negative is a negative, and 77 divided by -7 is 11. There are some shortcuts you can do when you have fractions and decimals within those equations. The first shortcut deals with fractions. An equation can be cleared of fractions by multiplying both sides by the common denominator. And you want to try to get the least common denominator, or you're just going to make your numbers larger. And then decimals can be eliminated by multiplying them by a power of 10. And so it's much easier to deal with integers instead of fractions and decimals. And so these shortcuts can help you get an equation a little bit simpler to deal with. Let's look at this one. So just looking at this, it looks pretty daunting. But if you take this and get rid of those denominators, you're going to have a much easier time. So we're going to look at our denominators. We have a 4, we have a 3, and we have a 6. These are our denominators. Now you could multiply them all the way across, but you may have a really large number. So what I like to do is I like to break it up into primes. So that is 2 times 2, or 2 squared. This is just 3, so 3 to the first power. And this is 2 times 3. So we have 2 times 3. And so when I'm thinking about the least common denominator, I'm going to look at all of these numbers. I have a 2 and I have a 3. And I need to take these and use the highest exponent for each of them. So by that I mean I have a 2 squared and a 2. I just need to use the highest exponent squared. And I have a 3 and a 3. Those are both to the first power. And so if I say 2 squared times 3, well, that is 4 times 3. My least common denominator is 12. The other way you can do this is you can take the largest of those numbers. So the largest of these numbers here is going to be this 6. So if I take that 6 and I just start going through the multiples of 6. So 6 times 1 is 6, 6 times 2 is 12, and then you will get to a number that both 4 and 3 go into. And once you find the multiple of 6 that both 4 and 3 go into, you have also found your common denominator. What you're going to do is you're going to take that common denominator and you are going to multiply every single piece of it by that common denominator. And you'll notice that I'm putting 12 over 1 so that you don't forget that you have a fraction, and you're going to cancel some things out here. So we're going to multiply every piece of it by that common denominator. Now, what this does is I'm multiplying fractions here, so I can cross cancel. The 4 goes into 4 and 12. I'm left with just 3. And now I have just 3 times x. and it's just over 1. So I don't have to write that 1. Here I can cancel the 3 and the 12. That's a 4. So I have just a 4 and an x minus 1. And over here, the 6 and the 12 cancel. 6 cancels with 12, gives me a 2. And I have the 2 and the x plus 3. And now I have a much simpler equation to solve. I am going to get rid of my parentheses with distribution here. 4 times x, 4 times negative 1. Over here, I'm going to distribute 2 times x, 2 times 3. And then I'm going to combine my like terms over here. 3 and 4 give me 7x. I don't have any like terms on this side. I'm now ready to get all of my variables to one side. Remember, do the opposite. Get all of my numbers to the other side. Remember, do the opposite. And don't forget, you do have an equal sign there. When you have all of your variables on one side, all of your numbers on the other, you are then ready to divide. And so once you're ready to divide, you're just going to take that 5, the coefficient there, and divide both sides. And you will get x equals 2. Now let's look at decimals. So once again, decimals, you're capable of multiplying and dividing and adding, subtracting them, but it is easier if you can just get rid of it. And so the easiest way to get rid of decimals is to first count. How many does each one have? Well, this one has 2 decimal places. This one has 1 decimal place, and you only have to worry about on the outside of the parentheses, 1 decimal place. And this has 2 decimal places. So the most that I had was 2 decimal places. So we're going to take multiples of 10 and get rid of them. If I have 2 decimal places, I want 2 zeros or 10 squared. And I am going to multiply everything by 100. So what I'm actually going to do is if I have 2 decimal places, I'm going to move all of my decimals by 2 places to get rid of them. So this 0.5, I'm going to move 1, 2, and that's just going to be a 5. This 0.1, I'm going to move 1, 2, and because I had a space, that's going to be a 10. And this, I'm going to move 1, 2, and that's going to be 165. And so now I'm going to rewrite my equation with those changes. Instead of 0.05 in, I'm going to say 5 in, plus, instead of 0.1, 10. Leave the parentheses alone. That doesn't have to be changed. And then this will be 165. Much easier equation to solve here. So again, I want to get rid of these parentheses first, leave everything else alone. Distribute to get rid of your parentheses. You want to combine your like terms here. So the 5 and the negative 10 are going to combine. You have that 200 that stays just leave that alone. Negative 5 in there equals 165. Then you want to move your numbers to one side, variables to the other. In this case, we only have one variable to worry about. So we can just just move that 200 over to the other side. Cancel here. That negative is going to stay with that 5 in. So leave that there. And then we have the 165 minus the 200 gives us negative 35. And then we can finish this problem dividing both sides by negative 5. and you will have that n equals 7. Last example I want to do really kind of throws everybody for a loop because you see that there are multiple variables in this one. And so we have this 7x, 18b, 5b, ax, and then they're telling us to solve for x. And you're thinking, I have way too many variables. What they actually want you to do is just get the x all by itself. And so when you have something like this, you're not actually going to come up with a numeric answer. You're going to come up with an answer that still has a lot of letters in it. Our goal is to get the x by itself. And so when we have an equation like this and they want us to solve for a specific variable, the first thing you want to notice is which variable do they want me to solve for? Well, they want me to solve for x. So when I'm trying to solve for x, I want to get all of my x's on one side, and then I want to move everything that doesn't have an x to the other side. So when we look at this, we see that I have a 7x over here and a negative ax over here. So I want to move that group that has the x in it over to the other side. And I'm going to do the same process. It is a negative ax or a minus ax. So I want to make it a plus ax. And I'm going to say plus ax over here. So I've actually canceled on this side. And on the left side, I have the 7x, the plus ax, the plus 18b. And on the right side, I just have the 5b. Now, this 18b does not have an x in it. So I want to take that 18b and I want to move it to the other side. It is a plus 18b. So I'm going to say minus 18b. And now I have canceled it from this side. I have 7x plus ax over here. And I have 5 minus 18b. So I have negative 13b right there. Now, here's where you want to use distribution. It doesn't look like distribution, but it is. We are undistributing. So just like you can put something into parentheses, you can take something out. What I want to take out is what they have in common. They have an X and an X in common. So I'm actually going to put that on the outside. And then I'm going to put parentheses and I'm going to put what's left over. Well, I have a 7 here. Don't forget you have a plus sign. And I have an A. I'm going to leave the other side alone for right now. Now, if you look at this, if you were to get this problem and distribute, you would say x times 7 is 7x. X times a is ax. So this is the same as that. We've just taken it out of parentheses. And if you'll remember, what's happening in between the x and the parentheses is multiplication. And so if I want to move that to the other side, it's just like if I had 5x over here, I would divide by 5. Well, now I have 7 plus a times x, so I'm going to divide by that 7 plus a. And I'm going to do that on both sides of this equation. And because I'm able to do that, I have now solved for x. Dividing by that entire group canceled the entire group, and I have just an x. And over here, I have negative 13b on top and 7 plus b on bottom. And I am done with that problem. So the last term I'm going to look at, we're going to talk about later on, but it is an excluded value. This is a value that would cause a problem in an expression. I want to give you an example. So if we had 1 over x, there's no problem with that unless x were to equal 0. What would happen if x equals 0? Well, if x equals 0, then all of a sudden I have 1 over 0. And that is a problem for x. We can't have 1 over 0. We are not allowed to do that. And so in this particular case, x would be an excluded value if x equaled 0. So x is going to exclude 0 there. Now, it's not always 0. For example, I could have 1 over x minus 3. Well, 0 is not a problem because then I would have 1 over 0 minus 3, which is just 1 over negative 3, and that's good. No problem there. But my excluded value here is something different. X here cannot equal 3. Why can't it equal 3? Well, 1 over 3 minus 3 gives me up 1 over 0. We cannot have that. So for this problem, 3 would be my excluded value. And that's what they mean by excluded value. Just to review solving equations, the first thing you want to do is clear any fractions or clear decimals. We want to get rid of fractions and decimals so that it'll be easier to solve. Then you want to simplify both sides of the equation. That may mean distributing, combining like terms, but you want to make sure that both sides are as simple as they can get. No terms that you could potentially add together. Go ahead and combine those, and no parentheses left. Then you want to put variables on one side and your numbers on the other. Variables on one side, numbers on the other. If you have extra variables and you're actually solving for one, you may have to factor things out. But your final step's going to be divide by whatever's in front of that x. Divide by that coefficient so that you now have that x completely by itself.